This is another simple interest problem, and it's another one where I'm looking for the rate instead of looking for the interest, right? I am still going to use our typical simple interest formula, I equals principal times rate times time. And I have been given principal. I've been given time, but a little bit differently than normal because I've been given it in months instead of years, and we'll deal with that in a minute. And I've been given, instead of an interest value, I've been given the future value. A is typically, and in our textbook, will be used as the future value of the loan. And so I've been told that after 9 months, my total value is $2,735, whereas my initial investment was $2,300. And so, well, what do I have? I have principal. I've been given principal. I have time, but again, we're going to need to do a little bit of work to the time to use it in the formula because we want time in years. And then I'm looking for R, so it's okay that one's unknown. I need I, and I don't have any I yet, so let's calculate the I first. I is going to be the difference between what I have in the end and what I had in the beginning, right? That's going to be the amount of money that was added to my initial investment. And so that'll be what I finished up with, and that's the future value. So the $2,735 minus what I started with. And so that'll be the $2,300. And so that'll be what, $435. And we can check that if we're feeling like we want to be extra certain that we didn't do something silly. So $2,735 minus $2,300. Make sure we're right. We are right, $435. Good. All right, so that's the I. That's the last value that we just didn't know that we needed. So we needed the I. Now we have the I. We needed the P. We already had the P. But T is doing something funny to us. We had T, but it's in 9 months. And we know that we're talking about yearly interest rates. We've been talking about yearly interest rates this whole time. And so that's what we want to keep talking about. And we've been given a time in months. So what am I going to do? Well, I probably ought to convert that time from months to years. A few different ways to think about doing this. You've probably already done it in your head, but let's write down kind of the analytical way to think about this. So if I've got T equals 9 months, one of the big things I can do to a number without changing the value of that number, just changing the way that number looks, is I can multiply by 1, right? It's called that multiplicative identity. It's that whole idea that A times 1 equals A, right? Anything times 1 is what you started with. Okay, well, the one that I'm going to choose, it better have months in the denominator, right? And it better have years in the numerator because I want the months to cancel and leave me with years for my units. So I better come up with a ratio of years to months where 1 year is the same thing as 12 months. 1 year equals 12 months, so that is 1. I have something divided by itself. They just look different because the units are different. And so now my months cancel, and I'm left with a value here of T is 9 over 12 years, or 3/4 of a year, or 0.75 years. Okay, back to our calculation. We want to take that I, plug it in for I. We want to take 0.75, plug it in for my time. And then we want to take the P that we were given, that 2,300 at the beginning, plug it in for principal, and see what kind of numbers we get. So my I was 435, and that's going to equal my 2,300. And I'm going to reorder this a little bit just because I have a number for T and I don't have a number for R. So I'm going to multiply that by 0.75 years. And then I'm going to multiply that by my rate. Excuse me. And so let's go ahead and do the 2,300 times 0.75. And that'll give me 1725. So I have 435 equals 1725 times R. Now, to solve for that R, I need to divide both sides by 1725 because the 1725 will cancel off the right-hand side. And what I do to one side of the equation, I have to do to the other side of the equation. So the reason I'm dividing by 1725 is that this divided by itself equals 1. So those cancel. It leaves me with an R on the right-hand side. The reason I'm dividing by 1725 over here is because, well, if I did it to one side of the equation, for this equation to remain true, I have to do it to the other side of the equation. And so what's that going to leave me with? That's going to leave me with, and I'm going to flip the order of this equation from left to right. So I'm going to write it R equals, and now I just got to run to the calculator and type in 435 divided by 1725 equals there. And I'm going to get something long here, and I'm going to round it to 0.252. All right, now again, that's a decimal. As an interest rate, it's probably more useful for us to think about this as a percentage. And so that's going to be 25.2% for my rate. That is a huge interest rate. But if you look at it, in less than a year, it gained $435. And so in less than a year, it actually gained quite a large percentage. 500 would be 25% of 2,000, right? If I'm going back to my estimation skills. And so I buy that this is, that ballpark, this seems like a very reasonable answer. I'm not saying I've checked this answer. I'm not saying that it's 100% right. But looking at that and saying, hey, wait a minute, based on my estimation skills, it's gone up, approximately ballpark 25% in under a year. So 25.2% seems like a reasonable answer. Hope that helps.